Next, continuity in an open interval. Question 1. Discuss the continuity of the function f given by f of x is equal to mod x. So to discuss the continuity, we need to understand the definition of modulus function. So definition of mod x is f of x is equal to x when x is greater than equal to 0. F of x is equal to minus x if x is less than 0. So f of x is equal to x for all the positive integers including 0, and f of x is equal to minus x for all the negative integers. So now we will check the continuity of this function at x is equal to 0. So first we are finding the value of the function at 0. So f of 0 is equal to 0. Second, we will find out the left hand limit of the function, that is limit of f of x as x tends to 0 minus, which equals limit of minus x as x tends to 0 minus, and when we substitute the limit we get the answer as minus 0, which is equal to 0. Next we will calculate the RHL, limit of f of x as x tends to 0 plus limit of x as x tends to 0 plus, which is equal to 0. So we can observe that the left hand limit, the right hand limit, and the value of the function at 0 all are equal to 0. Therefore the function f of x is continuous at x is equal to 0. Next, question 2. So discuss the continuity of the function f of x given by f of x is equal to x plus 2 when x is less than equal to 1. F of x is equal to x minus 2 when x is greater than 1. So where the value of the function for all the values of x greater than equal to 1 is x plus 2, x minus 2, and the value of the function for values less than equal to 1 is x plus 2. And we can see x minus 2 as well as x plus 2 both are polynomial function, hence they are continuous. We will check the continuity of this function at 1. So f of x we are substituting as 1. So f of 1 is equal to 1 plus 2, which is equal to 3. Next we will calculate the left hand limit of the function and right hand limit. So first we will consider the right hand limit, limit of f of x as x tends to 1 plus, which equals limit of x as x tends to 1 plus. So after substituting the limit we get 1 minus 2, which is equal to minus 1. Next, LHL, limit of f of x as x tends to 1 minus, which equals limit of x plus 2 as x tends to 1 minus. So which equals 1 plus 2, which is equal to 3. So we can observe that the left hand limit is not equal to right hand limit, minus 1 is not equal to 3. Therefore limit does not exist, and since the limit does not exist at 1, the function is discontinuous at the point 1. Next example. First one, find all the points of discontinuity of f of x where f of x is equal to 2 when x is less than 1. It is equal to 0 when x is equal to 1, equal to x minus 2 when x is greater than 1. So consider the function. So the function is divided into three parts, that is less than 1, add 0 and greater than 1. So again we will discuss the continuity of this function at 1. So f of 1 is equal to 0. Second, we will calculate the LHL. Limit of f of x as x tends to 1 minus is equal to limit of x plus 2 as x tends to 1 minus, which equals to 3. Next, RHL. Limit of f of x as x tends to 1 plus, which equals limit of x minus 2 as x tends to 1 plus. So on simplifying, we get 1 minus 2, which is equal to minus 1. So again we can observe that the LHL is not equal to RHL. Therefore the given function is not continuous at x is equal to 1. Hence there is one point of discontinuity, and that is 1. Next question. Find all the points of discontinuity of the function f of x, where f of x is equal to x plus 2 when x is less than 0, x minus 2 when x is greater than 0. So again we can see that the function is divided into two parts, that is values less than 0, values greater than 0. Question 3. Discuss the continuity of the function f of x is equal to x when x is greater than equal to 0, x square when x is less than 0. So the function is divided into two parts, that is the value of the function less than 0 and the value of the function greater than equal to 0. So we will check the continuity at x is equal to 0. So at 0 the value of the function is equal to x, therefore f of 0 is equal to 0. Next we will calculate the LHL of the function. So limit of f of x as x tends to 0 minus is equal to limit of x square as x tends to 0 minus. So 0 square is equal to 0. Next, RHL. Limit of f of x as x tends to 0 plus is equal to limit of x as x tends to 0 plus, which is equal to 0. So we can see that the left hand limit of the function is equal to right hand limit of the function, which is equal to the value of the function at 0, and therefore the given function is continuous at x is equal to 0. Next question. Prove that the function f of x is equal to x raised to n is continuous at x is equal to n, where n is a positive integer. So first we will consider the given function f of n. So we are replacing n with x with n. So we get f of n is equal to n raised to n, which is well defined. Next we will calculate the limit. Limit of f of x as x tends to n is equal to limit of x raised to n as x tends to n, which equals again n raised to n. So the value of the function at n is equal to limit of the function at n, and therefore f of n is equal to limit of f of x as x tends to n. Therefore the function is continuous at x is equal to n. Next question. Is the function defined by x square minus sine x plus phi continuous at x is equal to phi? So First we will write down the value, that is calculate the value of the function at pi. So f of pi is equal to x square minus sine x plus pi, which equals pi square minus sine pi value with 0 plus pi. So next, limit of the given function. So limit of x square minus sine x plus pi as x tends to pi is equal to pi square minus sine pi plus pi, which again equals pi square plus pi. So we can see the value of the function at pi and the limiting value both are equal. Therefore, we can say that the given function is continuous at x is equal to pi. Next question. Explain the function f of x is equal to x square minus 25 divided by x plus 25, where x is not equal to minus 5 for continuity. So again we will consider the given function. So to prove it is continuous, we are considering some arbitrary point such that c belongs to R and c is not equal to minus 5. So the value of the function at c is equal to c square minus 25 upon c plus 25, which on simplifying we get c minus 25. So next we will calculate the limit of the function at x tends to 0. So limit of x square minus 25 divided by x plus 5, which equals c square minus 25 divided by c plus 5, which is again well defined. So we can see the value of the function at a point c is equal to the limiting value at point c. Therefore, the given function f of c is equal to limit of f of x as x tends to c is a continuous function at x is equal to c. Next question. Examine the function f of x is equal to mod of x minus 5 for continuity. So first we will discuss the definition of mod function, apply the definition to the given example. So f of x is equal to x minus 5 when x is greater than equal to 5, and minus of x minus 5 when x is less than 5. So on simplifying, we get f of x at 5 is equal to x minus 5. So f of 5 will be equal to 5 minus 5, which is equal to 0. Next, LHL, limit of f of x as x tends to 5 minus. So the value of the function when x tends to 5 minus is minus x minus 5. So on substituting, we get 5 minus x, which is again equal to 0. Next, RHL, limit of x tends to 5 plus. So the value of the function is x minus 5. On simplifying, we get 0. So we can see that the value at f of 5, LHL and RHL, all the three values are equal, and therefore the given function is continuous at x is. Next, find all the points of discontinuity of f where f is defined by f of x is equal to mod x upon x if x is not equal to 0, and 0 if x is equal to 0. So again we are applying the definition of mod function. So we know that mod x is x when x is greater than equal to 0, and it is minus x when x is less than 0. So next, using the definition of modulus function, we will the example. So we will check the continuity at 0. So f of 0 is equal to 0. Next, LHL, f limit of f of x as x tends to 0 minus is equal to limit of minus 1, which equals minus 1, and RHL is equal to limit of f of x as x tends to 0 plus, which equals limit of 1, which is equal to 1. Next, we can see that LHL is not equal to RHL, therefore the limit does not exist. Next, we'll try to understand the continuity of greatest integer function. The function f from R to R defined by f of x is equal to step x, where x assumes the value of greatest integer less than or equal to x, is called as the greatest integer function. So let us consider some example. If x is equal to 0, then f of 0 is equal to a greatest integer function of 0. This is an integer which is equal to 0. Next, if x is equal to 0.12, then f of 0.12 is equal to uh, step function of 0.12, which is again equal to 0. So if x is equal to 0.99, again the value of greatest integer function will be again equal to 0. Similarly, for 1.08, the value will be equal to 1. If x is 2.5, again the value will be equal to 2. If x is 3, the value will be equal to 3. And if x is equal to minus 0.1, then the value will be minus 1. So here the function will take the value less than or equal to x. So the graph of greatest integer function is shown in this figure. So domain of this function is R and function is Z. So example based on that. Discuss the continuity of the function and defined by f of x is equal to greatest integer function of x. So here again we are considering the graph of greatest integer function and check the continuity along the number line, real number line, that is minus infinity to plus infinity. So let us consider some arbitrary point such that c belongs to z. So we will check the conditions now. So f of c will be equal to step c, again which is equal to c. Next, RHL. RHL is equal to limit of f of x as x tends to c plus, which will be limit of x as x tends to c plus, which is equal to c. So next, RHL, limit of f of x as x tends to c minus is again equal to step x, which is again equal to c. So limit of f of x is equal to as x tends to c does not exist. Okay, consider the next question. Find all the points of discontinuity of a function where f is defined by f of x is equal to 2 if x is less than 0, f of x is equal to 0 when x is greater than equal to 0 and less than equal to 1, and f of x is equal to 4x if x is greater than 1. So in this particular example, there are 2 points where we need to discuss the continuity of the above function, that is 0 and 1. So to the left of 0, the value of the function is 2x. Uh, in between 0 and 1, the value of the function is 0. And when it is greater than 1, the value of the function is 4x. Next, first we will check the continuity of the function at 0. So, so at x is equal to 0, the value of the function f of 0 is equal to 0. Next, LHL, limit of f of x as x tends to 0 minus is equal to limit of 2x as x tends to 0 minus, which is equal to 0. Next, RHL, limit of f of x as x tends to 0 plus is equal to a limit of 0 as x tends to 0 plus, which is equal to 0. So therefore we can see that LHL, RHL and f of 0, all the three values are same. So the function is continuous at x is equal to 0. Next, we will check the continuity at x is equal to 1. So f of 1 is equal to 0. Next, LHL is equal to limit of f of x as x tends to 1 minus. So the value of the function is 0. Next, RHL, limit of f of x as x tends to 0 plus, which equals limit of 4x as x tends to 0 plus 1 plus, which on simplifying we get 4. Next, we can see that LHL is not equal to RHL. Therefore, the function does not become continuous at x is equal to 1. So the above function is at 0. Next question. Find all the points of discontinuity of the function where f is defined by f of x is equal to minus 2 when x is less than equal to minus 1. It is equal to 2x when x is greater than minus 1 and less than equal to 1, and f of x is equal to 2 if x is greater than 1. So consider the 2 points where we need to check the continuity, that is minus 1 and 1. So the value of the function less than minus 1 is minus 2. In between minus 1 and 1, the value of the function is 2x, and when it is greater than 1, the value of the function is 2. So next we will consider, look, okay, we will consider the continuity of the function at x is equal to 1 minus 1. So we have two participants. So the next concept in continuity is finding the value of k when a function is continuous. So first example, find the values of lambda so that the function f is continuous at the indicated point. So in such kind of examples, we need to first calculate the limiting value, the value of the given function at the point. Then we need to calculate the LHL and RHL. And since the function is continuous, we can equate any of the three values here. Either we can equate LHL and RHL, or the limiting value of the function at that point, the value of that of the function at that point with LHL, or the value of the function with RHL. So we will try to understand using this example. So f of x is equal to lambda into x square minus 2x if x is less than equal to 0, 4x plus 1 if x is greater than 0 at the point x is equal to 0. So in the question it's mentioned that the function is continuous at x is equal to 0. We need to find the value of lambda, and also we need to check the function is continuous at x is equal to 1. Solution. So now we can observe from the given function that the value of the function when x is less than 0 is lambda into x square minus 2x, and when it is greater than 0 the value of the function is 4x plus 1. So we will check the continuity of the function at 0. See, at x is equal to 0 the value of the function will be equal to lambda into 0 minus 0, which is equal to 0. Next, LHL, limit of function as x tends to 0 minus, will be equal to limit of lambda into x square minus 2x, and again it will be equal to 0. Next, RHL, limit of f of x as x tends to 0 plus, which is equal to limit of 4x as x tends to 0 plus. So on plus 1, on simplifying we get 1, and we can it's already given in the question that the limit of the function uh, is continuous even though LHL is not equal to RHL. And so see, we can observe that LHL is not equal to RHL for any value of lambda. So they have asked us to calculate the value of lambda where the given function is continuous. But since LHL is not equal to RHL, the value of there is no value of lambda for which the function will be continuous. Next, at x is equal to 1, it is the function will be continuous because f of x will be equal to 4x plus 1, which is a polynomial function. Therefore, the function is continuous at x is equal to 1, and for any the function will be continuous. Next, we will discuss the second example, similar pattern. So find the values of k so that the function f is continuous at the indicated point. So we need to find the value of the function, uh, value of the k where the function is continuous. So again in such type of examples, we need to calculate the value of the function at the particular point, LHL and RHL, and then equate LHL and RHL, find the value of k. So f of x is equal to kx square if x is less than equal to 2, it is 3 if x is greater than 2 at x is equal to 2. So from the given function it can be observed that the value of the function is equal to kx square when x is less than equal to 2, and it is equal to 3 when x is greater than. So first we will calculate the value of the function at 2. At 2 it is kx square, so replace x with 2, we get 4k. LHL will be equal to limit of f of x as x tends to 2 minus, which will be again equal to limit of k as x tends to 2 minus kx square. So substitute x as 2, again we get 4k. Next, RHL will be equal to limit of f of x as x tends to 2 plus, which equals limit of, say, the value when the value of the function when it is greater than 2 is equal to 3. So RHL we need to substitute it as 3, and on applying the limit the value will be equal to 3. It will be equal to 3. So next, since the given function is continuous at x is equal to 2, we can equate all the three values, that is f of 2, RHL and LHL. So on equating any of the two values, any two of the three values, we get 4k is equal to 3 or k is equal to 3 by 4. Okay. Next example, find the value of k so that the function is continuous at the indicated point. F of x is equal to kx plus 1 if x is less than equal to 5, 3x minus 5 if x is greater than 5 at the indicated point x is equal to 5. So again we can observe that the function takes the value kx plus 1 when it is less than 5, and when it is greater than 5 the value of the function is 3x minus 5. So again we will first calculate the value of the function at 5, which will be equal to kx plus 1. So replace x with 5, we get 5k plus 1. Next we will calculate the RHL. RHL is equal to limit of f of x as x tends to 5 minus, which is kx plus 1. On substituting the value of the limit, we get 5k plus 1. Next RHL, limit of f of x as x tends to 5 plus limit of 3x minus 5 as x tends to 5 plus, which is equal to 10. So again we know that the function is continuous at x is equal to 5. So equate all the three values f of 5, LHL and RHL, and on simplifying we get 5k plus 1 is equal to 10, or k is equal to 9 by 5. Next question. Find the values of a and b so that the function f is continuous. Okay, so here instead of k we need to calculate two values, that is value of a as well as b. So the function is defined as f of x is equal to 5 if x is less than equal to 2, ax plus b if x is greater than 2 and less than 10, f of x is equal to 10, 21 if x is greater than equal to 10. So we can see there are 2 points in the given function where we need where it is continuous. The first point is 2 and the second point is 10. So first we will simplify considering the point 2 using the point 10. So see the limit of the function at 2. So first we will calculate LHL, RHL and the value of the function at 2. So at x is equal to 2, f of 2 will be equal to 5. LHL will be equal to limit of f of x as x tends to 2 minus, which equals limit of 5 as x tends to 2 minus, which is equal to 5. RHL limit of f of x as x tends to 2 plus, which equals limit of ax plus b. On simplifying we get 2a plus b. So again the function is continuous at 2. So f of 2 will be equal to LHL will be equal to RHL. So on equating LHL and RHL, we get 2a plus b is equal to 5. This we will consider it as equation 1. Then we will calculate the values at 10. So at x is equal to 10, the functional value f of 10 will be equal to 21. LHL will be equal to limit of f of x as x tends to 10 minus, which is ax plus b. So on simplifying, we get 10a plus b. Next, RHL limit of f of x as x tends to 10 plus, it is 21. So the value limiting value is 21. Next, we also know that the function is continuous at x is equal to 10. So f of 10 will be equal to LHL will be equal to RHL. So on simplifying, we get 10a plus b is equal to 21, which gives us the equation 2. So now we simplify the equation 1 and 2 to obtain the value of a and b. So the 1 and 2 are simultaneous linear equations. So on solving, we get 10a plus 5b is equal to 25. 10a plus b is equal to 21. So by using the elimination method, 10a and 10a will cancel. 4b will be equal to 4, or b will be equal to 1. And substituting the value of b in either one of the equation, we get a is equal to 2. A is equal to 2. So such type of examples will be asked for 4 marks in the part E of the question paper. So solve all these examples, that is finding the value of k, finding the value of a and b, finding the value of lambda. Next we will discuss some more examples related to the same concept. So find the value of k so that the function f is continuous at the indicated point. So f of x is equal to kx plus 1 if x is less than equal to pi, and cos x if x is greater than pi at x is equal to pi. So the function takes the value kx plus 1 when it is less than pi, and the value of the function is cos is greater than pi. So we'll calculate the value of the function at pi. F of pi is equal to pi k plus 1. LHL is equal to limit of f of x as x tends to pi minus. So on simplifying, we get pi k plus 1. Next, we will calculate the RHL. So limit of f of x as x tends to pi plus, which equals cos pi, and the value of cos pi is equal to minus 1. So we know the function is continuous at x is equal to pi. So f of pi is equal to LHL is equal to RHL. On simplifying, we get minus 1 is equal to pi k plus 1. Minus 2 is equal to pi k, or k will be equal to minus 2 by pi. Next example, a very important question. Find the values of k so that the function is continuous at the indicated point. So f of x is equal to k cos x divided by pi minus 2x if x is not equal to pi by 2, and it is equal to 3 if x is equal to pi by 2. A solution. So we are solving this by the first definition of continuity, that is the limit of f of x as x tends to a is equal to f of a. So to simplify this, we first calculate f of limit of the function and then calculate f of a, equate both the values to find out the value of k. So limit of k cos x divided by pi minus 2x is equal to f of pi by 2. So first we will simplify the LHL. So see, since the LHL part is in indeterminate form, we are making use of substitution method. So we are substituting x as pi by 2 minus x. So k we are taking out constant, and then see in place of cos x we are replacing it as sine of pi by 2 minus x. 2 is common in the denominator, so we get pi by 2 minus x, which equals f of which equals 3. So now we know that the formula from the limit, that is limit of sine theta upon theta as theta tends to 0 is equal to 1. So using the same formula in the LHL, we get the limiting value as 1. Limiting value as 1. So k by 2 into 1 will be equal to 3, or k will be equal to 6. Okay. So we need to uh, make use of the limit formula. So just we need to mention the formula in that particular step and simplify it. So this particular example has occurred repeatedly. Mm. And one question is fixed on finding the value of k every year. Okay. So go through all the questions, solve them. If any doubts,